start. Okay. Very good evening to everyone. Good afternoon, good morning around the world on planet Earth. All right. So I'm Dr. Chong Hon Yu. I'm from the Astronomical Society of Penang. And with me are my members. In pursuit, we call him CK lah, don't forget. And then our Kenny, CK Low, you can see on the screen, and our wonderful host Michael Tew. All right. So we are on Penang Island. For those of you who are on the world not familiar with Penang Island, Penang Island is a small island on the northwestern corner of Malaysia, Malaysia. And to the west of Penang Island is and to the north of Penang Island is of course this what is called Thailand. And Penang Island is on the northern entrance of the Straits of Malacca, where every day many ships will pass through. So it's the most important commercial waterway in the world. Right? So I'll now share the screen on today's talk. Okay. You can see my screen, huh?
Yes.
Yes.
Wait. Can see, huh?
Yes, can see now.
The PowerPoint, okay. So tonight's talk is got two parts: opposition of Jupiter and Saturn, and then now our member CK is waiting in his observatory in Penang, right? And Kenny also is in observatory will show us what we can see. Hopefully, you can catch later on in this program tonight. Live Jupiter and live Saturn. And also the recent bolide meteor incident in Penang, loud explosion and flashes of light. Okay, so before we go into the opposition of Jupiter and Saturn, I must show you this picture. Wow! Now remember, our member Michael Chu took this picture. Of course, in your screen may not look big, but if you see on the screen, on the left is Jupiter with the two moons, and on the right is this what we call Saturn. All right, was taken in the 21st December 2020 last year, Michael. And I can see on my screen what a beautiful picture. What we call fine detail. So I will consider that this is the best Jupiter Saturn conjunction picture ever taken from the world on 21st December, right? And the angle separation is 0.1 degree between these two planets. Remember, the moon's angular diameter is half a degree, no? So this is 1/5 the angular diameter of the moon. So close, right? Taken from Henry Observatory, a school in the what you call in the center of Georgetown on Penang, right? And taken with a 9-inch APM TMD reflector with this what you call QHY what you call camera with this what you call RGB filter wheel, right? Of course, we processing lah, right? So beautiful. So now so congratulations to Michael. So now we are talking about the next great conjunction that will come as close as the recent one will be about 19 years from, 69 years from now, 15th of March 2018. So now I go back to CK. So CK, can we move over to your observatory to look at
Okay. Yeah, okay. Hold on for a while. I'll share my screen.
Okay, I'll unshare first. Okay. CK, you're on?
Okay. I'm sharing now. Hold on.
Okay. So we hope to be able to see live Jupiter and Saturn, right?
Yeah.
Jupiter and Saturn are very big now because they are both close to opposition or just past opposition. So CK, you're on?
Okay. Can you see my screen?
Yes, I can see your screen. Can hear your voice.
Yes, can see the moon. Very nice.
Yes, the moon, right? Okay, this is the live view of the moon. Currently taken with it's a small telescope only, just a small telescope, and we just wanted you to have a preview of what's coming up next because right now the moon is going to set soon. In a short while, Saturn will rise up higher, and Jupiter will be rising up also. So we'll listen to Dr. Chong talk first. Then, if the sky is clear, we'll come back to my observatory, and I'll show you the live view of Saturn and Jupiter. Okay.
So thank you, CK. So when CK will talk later, we'll show you the live view of Jupiter and Saturn from the tropical island of Penang. All right. So now we go to. You can see my PowerPoint, huh?
Yes, loading now. Yes.
Coming.
Okay. So now we talk about now earlier was of course the great conjunction of Jupiter and Saturn. The next close one will be in 2018. But this one, of course, we have to be super lucky. It's possible I check internet. This is the big one. Occultation of Saturn by Jupiter. 10 February 75 to 41. About 5,500 years in the future. You simulate is possible. So this is the simulation. So at that time, 35, 41, Jupiter and Sun will block Saturn occultation like this. But then, of course, in the future. Anyway, the present moment, two conjunction of Saturn and opposition of Saturn Jupiter is great, and last year's great conjunction of Saturn Jupiter was also great. All right. So we now talk about Saturn opposition. Already it's past. So today is the 14th of August. It was on the 2 p.m. afternoon time, Malaysian time, 2nd of August. For the Malaysian internet, Malaysian time is UTC plus 8 hours. Greenwich Mean Time plus 8 hours. UK time plus 8 hours. All right, that was the time, exact time. But of course, if you are in Malaysia at that time, cannot see Saturn because daytime. But what I mean is that there is a time when they are aligned. The sun, can you hear me? Hello?
Yes, can hear you.
Well, yep. Okay, that was okay. So now where are they now? So now the Saturn and Jupiter is just rising from the eastern horizon. They are in the constellation of Capricornus. Saturn here, Jupiter, all right? And so what's meant by Saturn opposition is the sun in the center and the blue dots, the Earth orbiting around the Earth, like the sun. The Earth orbit around the sun. So sun, Earth, and Saturn. So looking down from Polaris, the pole star, onto the plane of the Earth of Saturn's orbit around the sun and the Earth and Saturn are in the straight line. So this is called the Saturn opposition. August 2nd, 2021. It passed already. All right. Now the thing is, the angular size of Saturn during the opposition is 18.4 arc-second. Now this is a bit small compared to the angular size of the moon, which is 1,800 arc-second, but still not small. I estimate that this angular size of Saturn during the opposition is about the size of the planet Aristarchus of the moon. So you remember, even a small telescope, you look at the moon, maybe later CK show us where is Aristarchus on the moon. So with a small telescope, you can see that the crater, the medium-sized crater called Aristarchus on the moon. That is the size of Saturn during the coming this present opposition. Right? So the speed of Saturn, of course, is moving like that. All right. Now, and then Saturn's closest to the Earth. 5 hours later. So I repeat, the opposition is 11 a.m. But it's 2 p.m. on 2nd August. But the closest to the Earth is 7 p.m. 5 hours later. So in other words, the opposition and the closest need not be the same. All right. If I can go back to this view, it's like this. So it's that this is the sun. This is the orbit of the what they call Earth around the sun. This is the orbit of Saturn around the sun. So the basis is that when the what they call the Saturn is there, the Earth is here. So it doesn't mean that its opposition time it must be closest to Saturn, right? So the Saturn have to move a bit longer. 5 hours later, then Saturn is the closest to the Earth. So opposition and closer need not be the same, all right? So theoretically, you said I must take Saturn closest to the Earth. Don't take an opposition. Take at the closest. Okay, then is technically is correct. All right. So now we go back to the presentation. Okay. So now at opposition, the Sun, Earth, Saturn alignment will never be on a straight line. Some of you may think that looking from Polaris, you see the Sun, the Earth, and Saturn in a straight line. So actually, the position of the Sun and the Earth and the Saturn is on a straight line. That's not the truth. The idea is this. This is looking down from Polaris. So if you look at this age-wise, the thing is there are two planes considered. The orbital plane of the Earth and orbit around the Sun and the orbital plane of Saturn also are not the same. So in other words, the orbital plane of the Earth is tilted with respect to the Sun, to the Saturn, about 2 degrees, So in other words, if I move from the Sun to the Earth, taking into account the orbital inclination of the Earth's orbit with respect to Saturn orbit, so that from the Sun, the direction go up, you have to go up the slope to the Earth, and then go down the slope to Saturn. So from the Earth here to go down to the orbit plane of Saturn is about 5 million kilometers. So Earth is still 5 million kilometers above the Saturn orbital plane above the Sun. So in Saturn opposition does not mean that the sun, Earth, and the Saturn is exactly in a straight line. It's only in a straight line if you look down from Polaris, straight line. But you look at it the other way, it's not in a straight line, right? So this is the case. So Saturn's orbital plane is inclined at about 2.5 degrees relative to the Earth's orbital plane, right? So now you see, so this picture or the normal picture of Saturn is not correct. So all the planets do not orbit the sun on the same plane. Some of them are tilted higher, lower, and so on. Not a single planet will orbit the sun at the same orbital plane as the other planet. The worst one is, of course, our previous sibling called Pluto. Pluto's orbital plane of inclination around the sun is even higher, right? So that's it. So now, in other words, the sun go up the slope, then go down the slope to Saturn. So that's meant by Saturn opposition, right? So now there's another thing you must remember. The sun is the center, the Earth is on the left, and Saturn is even further left. So now we are in the left situation where it's called Saturn at opposition. So Saturn, Earth distance is very close. So Saturn is big. On the other hand, we have the second case is sun in the center, on the left is the Earth, the right is Saturn. So now it's called the what? Saturn at solar conjunction. All right, compare again. Saturn and opposition big, Saturn at solar conjunction small. So this is another one. So you remember every outer planet like Jupiter, Saturn, and so on, you have opposition, you have conjunction also. Right? And another technical detail is called quadrature. So here the sun, the Earth, Saturn at opposition, Saturn at solar conjunction. And if Saturn moves over here, 90 degrees here, so Saturn will be at this quadrature. If Saturn moves over to the other side, then Saturn will be also at quadrature. So these are the technical terms, right? But this month, Saturn will be opposition, right? So this is a picture of Saturn by Cassini. So beautiful Saturn with all the rings, right? So now we can ask ourselves the question, can the perfect Saturn opposition ever occur? That means, actually, if you look down on the Sun, the Earth, and Saturn, the Sun-Earth line, Saturn line, looking from the Polaris, is a straight line. And you look at the other way, along the orbital plane of Saturn, orbital plane Earth, Saturn, Earth, and Sun also on a straight line. Can this occur or not? Okay, the answer is, of course, very unlikely, all right, but can occur with a very tiny possibility. So if anyone want to ask the question, you can ask it. I can answer later on at the end of the presentation. If you don't ask, then I won't answer. So can the perfect Saturn opposition occur where from Polaris, straight line, and the orbital plane also straight line? Can or not? The answer is can, but very, very low possibility, right? So now Jupiter opposition is at, not yet, 20th of August, next Friday. Today is Saturday, 14th. 20th August is next Saturday, morning, 8 a.m. But sorry, that time is already daylight. So Malaysian cannot see because got daytime. Unless, of course, you can still track the Saturn during daytime if you want, right? So there's Saturn opposition, Jupiter opposition, 8 a.m., 20th August. And the case is like that, the Sun, the Earth, Jupiter. And the same thing is the orbital plane of the Earth around the Sun and orbital plane of Jupiter around the Sun are not the same. So again, Sun, Earth, Jupiter is on a straight line looking down from Polaris. But looking at the edge on the orbital plane, the Sun, Earth, Jupiter line is not a straight line. Not a straight line. Okay. So this is the meaning of Jupiter opposition means only from Polaris, you see the Sun, Earth, Jupiter, a straight line. Okay. So Jupiter closest to Earth is at 1 p.m. 20th August. So Malaysians want to take this closest one, 1 p.m. 20th August is also afternoon. So cannot do it lah. But if let's say it is 1 a.m., then you can see lah. So you don't, if you want to take opposition, make sure you take opposition, that one picture, and also the closest opposed, also another picture, few hours later. Then you can claim that you really took both. But this time is daytime. So what to do? So you take it during night time, right, which is what? Early morning of 20th August or late in the evening of 21st August, okay? So the angular size of Jupiter is big, 43.8 arc second, all right? So I estimate this is about the angular size of the crater Copernicus on the moon. Copernicus, one of the prominent craters, no? So Jupiter is big, as big as the crater Copernicus on the moon, seen from the Earth, right? So now, speed of Jupiter is this speed, 47,000 kilometers per hour, and Jupiter's orbital plane is inclined at 1.31 degrees relative to Earth's orbital plane. All right. So now I'm going to show you the normal picture of Saturn, Jupiter. Everyone knows. Show you the latest. This is by Juno. Remember, some years ago, NASA sent a beautiful spacecraft called Juno. So this is taking at one of the polar region of Jupiter. Look at the strange picture of the poles of Jupiter. And look at the clouds, so detailed. Great red spot. Cloud feature, very nice, no? By Juno. Again, by Juno. So detailed, you know. So it's a flyby of Jupiter by Juno. Juno is still orbiting around Jupiter, is still sending back a lot of pictures, and also the moons of Jupiter, right? So this is where we are now. Jupiter and Saturn is in Capricornus, all right? So Saturn's opposition is over, 2nd of August, but Jupiter opposition is coming next Friday, right? 20th of August. So now, one more comment before we pass back to CK is the solar system is now much less chaotic, right? Much chaotic. What do you mean by that? Actually, now the solar system, you know, is about 4.6 billion years old. The solar system is about 4,600 million years old, all right? Previously, when the solar system was much younger, the solar system was very chaotic, meaning the orbits of the planets after some time cannot be predictable because of gravity. Some of the planets can be kicked out of the solar system or can change orbit, right? But now it's now much less chaotic, meaning that, all right, it's more or less quite orderly, but there are some aspects of the solar system which are still chaotic. For example, the two moons of Saturn called Pandora and what they call this, Prometheus, right? The orbits of these two moons around Saturn are very chaotic. So they can change within a few days, it can change orbit because of chaos. So basically chaos is like that. A slight change is due to gravity. A slight change, initial change in the orbit of Prometheus now can cause a big change later. So when the solar system was much younger like this, all right. So a slight change now in the orbit of one object can have a big change later. So now the scientists have made a lot of simulation that actually they can simulate well the behavior of the planets orbiting the sun up to tens of millions of years into the future. Let's say 100 millions from now, will the orbits of the Jupiter, Saturn be the same? They may change. For example, we know that the after the sun was formed, the first planet formed was Jupiter. The youngest, the oldest planet is Jupiter. Later on, Saturn. But when both Jupiter and Saturn were formed, these two planets were much closer to the sun, even as close to the sun as Mars. But because of the gravity effect, the Jupiter migrated out from the old orbit to the present orbit. So previously, orbits of Jupiter and Saturn were much smaller, you know. So in other words, in the future, say maybe 100 million years from now, or even in the future, the orbits of some of the planets may change, right? Very unlikely to have some of the planets being kicked out of the solar system, because those that have been kicked out would have been kicked out already. So quite stable, but there will be still changes. So basically, they say that the solar system now is not entirely predictable; it's less chaotic, all right? That's the meaning of it. So now we go to the. So Michael, can I go to the bolide? Okay, go to bolide. Can you hear me, Chicken?
Yes, can hear you.
So Chicken, anything on your side? Chicken, anything on your side to show? Okay, now I go. So now we come to the very important thing, 21st of July, 2020. So if you don't mind, I will give an anecdote. I mean, what I heard from people I talked to and from the WhatsApp. Bright flashes and a loud bang in the Penang during the early morning of 21st July 2021. Unfortunately, it occurred at 5 a.m. when most people are asleep. At the most, you can hear the bang in their room. If only it occurred 1.5 hours later, 6:30 a.m., then a lot of people wake up, they can see. Or it occurred at 8 p.m. at night when people are still awake on the road, you can see better, right? So what happened is, I woke up around 6, 8, I saw on the WhatsApp, there's this CK, CK said, anyone heard a loud bang at around 5:02 a.m., right? And then he said, I can hear from Teluk Kumba. Teluk Kumba is in the southeastern corner of Penang Island, all right? Then he said, possibly a fireball. Then another society member, Alex Un, said, I thought it was thunder. Sorry, CK. Still on CK, possibly a fireball. I thought it was thunder. It has a distinctive sonic boom, all right? So a lot of message. So then this Alex Un, also near to southern part of Penang, he heard just a bang, no echo. my ceiling rattle a bit now. This my ceiling rattle a bit gives a lot of information, you know. The ceiling will not rattle. It is rattled by a high frequency sound. High frequency sound cannot rattle a ceiling. Only low frequency can rattle. So this is what? This is the low frequency sound, all right? The infrasound. Infrasound meaning the sound beyond the lower limit of human hearing. Human hearing is what? 20 hertz to 20 kilohertz. So this ceiling rattle beat is caused by the below 20 hertz sound wave, right? So then a lot more coming by CK, by Chichen, by Michael, a lot of people, by I will quote a few more because there's so many messages, so all their own personal one. So I think CK said I was outside and it felt like something falling down and I died. I didn't see any lights. There was a flash, I think before the boom. That's why I thought it was thunder. Then CK said, wait for Kenny. That's CK. Wait for Kenny to see if he set up. Then he set up, called it his camera, and Kenny's camera actually took a video of the body. Oh, what could have happened? This is Kenny. Oh, what could have happened? I missed it. I stopped observation at 1 a.m. as I worked this morning. That's Kenny. All right. So after that, there were so many messages coming in. So I just summarized earlier. So actually, this picture was taken by CK in his observatory around just before he heard the boom, right? When he went back to his house. So this was the Ring Nebula. I think this is a meteor. The meteor satellite. A meteor. Right? No, could be I don't mean meteor satellite because 5 a.m. could be satellite. So this took it just before he heard the boom, right, CK? So basically, reports keep coming in left and right everywhere. All right, so we barely have time to follow all the messages. So what is this? That people have heard the bang all over this part of the Penang Island, from Georgetown, from Tanjung Bunga, Georgetown, from my house in Jelutong, from what do you call this, Sungai Ara. A lot of people heard it, and also flashes of light. And CK's place is in Teluk Kumba, the extreme southeastern corner of Penang Island, all over. And there's a report from Kulim also. All right, Kulim is just to the east of Province Valley Sea. They heard the boom and the flash also. Right, so all over you heard it. So a lot of report. And then Kenny, Sungai Ara, he got this in his all-sky camera, and this came big news. You know, a lot of people reported it. So he got the bolide. He got the bolide, bright bolide, with his all-sky camera. So why is it all-sky camera look like human eye? Because the light pollution is so bad in his house. He cut down the light so it look like an eye. He cannot be a perfect circle. So to reduce the light pollution, so you can see the bright bolide.
Okay. Actual fact is I do not want to take my neighbor's window and my windows.
Okay, so
I blocked that. Yeah.
Yeah, correct. Yeah. He mentioned that. Okay, I forgot. So if you make a full circle, that means you can see his neighbor's house to the top side and the bottom side. So not nice. I can see a bit of here already. So then you can see the bolide. All right, it was reported in the news. All right, and then now from all the reports coming in, so now I want to show you the video. I'll show the video now. All right. So in my house, got the video, and then a lot of people also got a video. So now I show this video from Kenny's house in Sungai Ara. Okay, I'll show. This is a video of the bolide flying over one of the side wall of his observatory in Sungai Ara. Okay. Not yet. It's from here, top right hand corner. Look, I'll tell you when. No sound, just the light. Top right hand corner there on the top here. There. Okay, that's it. So this you can get a lot of information, no? So this Kenny informed me that direction of travel is from southwest to northeast, right? And then there's another one somewhere in Sungai Ara. Okay, look at the reflection of the roof of the car. Look, two flashes of light, and then you saw the color of the flash, blue light, and this another one. The sound, the same house. Can hear one boom, two flashes of light, and one boom. All right. Now this another place I think in Sungai Ara also.
Dr. Chong.
Yeah.
I wonder, is it possible I interrupt you for a while, because right now the setting is up there. The cloud is coming in also, so I quickly share the view of Saturn first before the cloud coming in.
I stop sharing now. So
yeah, is it okay? Yeah, come.
Okay, you're on. Good.
Yeah.
So now again, in Malaysia, what? Stargazing is bottom of the cloud gazing.
Okay, sorry about that, because I'm actually rushing between the clouds.
This is live Saturn, huh?
Yeah, this is live Saturn from my telescope hooked up to a camera. So it's not a very good view because the Saturn is just rising up. So what you can see that actually the Saturn is like dancing around. Okay, dancing around is because our atmosphere is there's a turbulence there. Then it causes what we call as a seeing. So it will disrupt. Then now you can see that the Saturn is a bit dimming because the cloud is coming in.
Yeah.
So just in time for you to show it because there's a big cloud group coming in, and now you can see Saturn is gone. So that's what I was trying to show you. So hopefully, we continue with Dr. Chong talk first on the bolide. Then
back again.
yeah.
It's back
Sorry.
Again. No, the Saturn is back again. Can see now.
Yeah, it's Saturn back again, but I don't know how long it will be back. But just a preview to the viewer lah, because Saturn just rising up. If the sky is clear, definitely we'll come back to the observatory, but I think now Dr. Chong will continue with the bolide thing first.
Before I go back, I go to share my thing. I will let the people know that CK's observatory in Pulau Botong is in the center of the Bali Pulau Durian Paradise. Where surrounded is obviously a lot of durian trees, So the durian season for these guys is over, but this year durian tastes very nice, Okay. So now I go and share. Okay, so now we go back to the other live. Look at the flash, look at the flash on the sideboard here. Look at the flash here, the light. About to come. One, 2, 3. 3 flashes of light. Okay, you can see 3 flashes of light and one boom, One boom. And there's another one. Video. This is only the sound. So on the top left, you have the CCD camera, the time exact to the accurate to the last second. You hear the sound? One boom. Okay. Now one more here. Look at the ceiling of the car. Hey, sorry. This one. No, never mind. This one is in Sungai Ara, next to Kenny's place. See, top right hand corner. There you are, like this. So with all this information we gathered, all right, don't give it the details lah. So we found out that basically the first sound was heard in Tanjung Bunga, all right, and Tanjung Bunga is 49 kilometers from the point of the explosion, because from the timing of the sound you get, how many seconds to reach you, you know the distance of your detector to the source of the sound, 49 kilometers, right? The source of explosion from Tanjung Bunga. Jelutong is my house, 56 kilometers away from the point of explosion, and Sungai Ara, all right, is 63 kilometers. So from these 3 information, we can get these things that based on this. Though this one done by Kenny, so the first big circle is of course what you call centered on Sungai Ara. Then the second smallest circle is centered on Jelutong, and the smallest circle is centered on Tanjung Bunga. So all 3 of them seem to touch each other here. So there's a kind of an error here because of the fact that they are at a tangent. We don't know exact. So within this region, so Kenny put here lah. This is where the source of the explosion is. There are a lot of calculation. So another reporter from Vibe said it could be here on land, right? Which is where in Gurun, right? But we know that basically this Kenny said again could be definitely to the north of Penang. So the final conclusion is to the north of directly to the north of Penang, north of Tanjung Bunga here. All right. So a lot of things were done. All right. So Kenny also made some calculations, or this Kenny's calculation to the north here. So 49 kilometers to the north of Tanjung Bunga is the source of the explosion. The source of the explosion is not on the ground at 49 kilometers north of Tanjung Bunga, somewhere high in the atmosphere. Remember, the Chelyabinsk meteor exploded 2013 or 11, 30 kilometers from the Earth's surface it exploded. So I estimated that the height it exploded must be at least 30 kilometers or higher, but not of Tanjung Bunga, 49 kilometers. So Kenny did a lot of detailed calculation, a lot of detailed calculation. I don't put detail. So finally, it's to the north here. And actually, to the north here, you look carefully, we hope that we have to check the wind condition, you know. So one of our members, Sabrina Chan, tried to check with the Penang Airport Kaji Cuaca, what we call weather station, weather. On that time, they check weather report at different heights from the Earth's surface, they know the weather. So on that morning, you see whether the wind, we hope that the wind is blowing to the east. So if the debris of those parts of the bolide exploded blown east, where fall on dry land, and not on the sea, on dry land, right? And of course, at the same time, Kenny suggested all along the coastal area of Kedah, from Sungai Patani coast right unto Kuala Perlis, maybe people will heard the sound, right? So this is it, the calculation. So now we say that the bolide has 3 explosions, right? Because the 3 flashes of light occurred high in the atmosphere, 40 kilometers, 9 kilometers to the north of Tanjung Bunga. That's more or less what we concluded, right? So all the 3 flashes of light were seen. Now 3 flashes of light, each of them produced 1 boom. By light, you see, hear 3 boom. But by the time the sound of the 3 loud bangs reached the Earth's surface, the 3 louder bangs had merged into 1 even louder bang. Because know that sound has a much longer wavelength, sound energy, than light energy, light frequency. So longer the wavelength, it can merge, you know. So light, you see as 3 individual points of light. Got short wavelength of light, very short. But sound wave with long wavelength, so when you travel long distance, the 3 loud bangs will merge into 1. So actually there were 3 bangs. So if you are near to the bang in the sky, you can actually hear 3 bangs. But on the ground, maybe about 50 kilometers from the bang. So by the time you reach the Earth's surface, they all merge into 1 bang. So how to calculate is very simple. They said that CK mentioned, and then Alex, that like thunder, they mentioned like thunder. I checked carefully. So thunder, the power level is about 110 decibel, right? Not the loudest, not the softest, but quite loud, 110 decibel. And that we know from physics, 0.1 watt per square meter. That's a power. And the distance from Tolokumba to 49 kilometers north of this Tanjung Bunga is distance 75 kilometers. So 75 kilometers, you can hear 110 decibel, you know. So knowing the speed of sound, and we know the inverse square law of sound transmission. That means every double the distance, the sound will drop by 1/4. Triple the distance, the sound will drop by 1/9, you know. So knowing that, you estimate that at the source of explosion, all right, the power generated by the explosion is 562,500,000 watts per square meter. And then we assume that the explosion, only one explosion, at the moment explosion, instant explosion, the fireball had a diameter of 20 meters. This is an estimate. And the duration of explosion is 2 seconds. Then the total energy emitted is about 1.4 trillion joules of energy, equal to about 2.23% of the Hiroshima bomb. Remember, Hiroshima bomb explosion is 15 kilotons TNT equivalent. So this Penang bolide is about 337 tons of TNT equivalent. TNT is what? The most powerful form of explosion called dynamite, invented by who? Alfred Nobel. The Nobel Prize winner invented dynamite, you know. So in a sense, because of Alfred Nobel, 1900, you give the idea of the Nobel Prize. He invented dynamite, which caused the war possible, you know. And yet, Nobel Prize. So 337 tons of dynamite TNT is no joke, you know. Imagine you have 1 ton of TNT. How many sticks of dynamite in 1 ton? Many sticks of dynamite. With 1 stick of dynamite, you can blow up a big structure, you know. But 337 tons of TNT, a lot of explosive power, you know. So now we go to this. I've checked a lot of research articles. I find the closest to our Penang bolide is this one. 7 July 1999 in New Zealand, in Hawera town. And it's published in the New Zealand Journal of Geology and Geophysics, these two authors. Very interesting one. Very similar to the Penang bolide. So I'll read a bit more detail. So not only you can see and hear, they also got seismic detection of this pipe. What is the seismic detection? Big explosion, no? The explosion was 33 kilometers in the Earth's atmosphere, came down and hit the Earth's surface and caused the vertical surface of the Earth to move in the vertical direction. Caused what? Seismic wave, earthquake, minor earthquake. And this was detected in other types of data like light and so on. Right? So I read a bit of the extract. In the afternoon of 7 July 1999, a meteor estimated to weigh up to 10 tons. So that means the meteor that exploded in Penang also about 10 tons, 10 tons, for example, consider it like the density of, say, asteroid. 10 tons has a diameter of 1 meter. 1 meter rock has 10 tons weight. So 10 tons enter the Earth's atmosphere to northwest of New Zealand, traveling from north to south. Visual observers between Warangay and Timaru reported the path of the fireball across the sky before it exploded 33 kilometers above the small Taranaki town of Hawera. United States Department of Defense satellite detected the terminal blast. This detonation produced a quasi-spherical atmospheric shock wave that deeply coupled to the ground, generating a signal that was recorded by 18 seismograph stations that form part of the geological hazards monitoring network operated by the Institute of Geological and Nuclear Sciences. We know that New Zealand is in an earthquake-prone area, so a lot of seismic stations all over New Zealand. So they detected the seismic signal due to the bolide. All right. So basically like that. New Zealand, you go to North Island. Here you have Auckland, the big city, and passing to the south, and just before hitting Wellington, the capital city, and this is South Island. So came from the north, entered the Earth's atmosphere, and just before this part, just into the land, it exploded. All right. So I don't give you all the details. Just look at it. So around here, a lot of seismograph stations. People saw it. They took a light also. So basically, from all this, they analyze it. This is the seismograph data. All right. That means, so if that day, let's say on the Earth's surface, somebody chuchuk a seismograph into the Earth somewhere in Kedah, they could have detected the seismic wave due to the bolide explosion. But this is New Zealand a lot. And this, they were able eventually to simulate this flight path coming from north to the south, exploded. And this is a hemispherical type of explosion and so on. And even the sonic boom carpets. A lot of things can be done like that. So basically what I'm saying that in Malaysia, in future, if you want, not to say as detailed as the New Zealanders, setting up of the Malaysian bolide meteor network. Some of us, we have all-sky camera, maybe on our cameras, we can even attach a sound detector, accurate one, and so on, and so on. So maybe we can get more detail. But we know that, for example, the Chelyabinsk meteor exploded in southern Russia. The infrasound, the explosion originally was audio. It went further and further away from the point of explosion, become lower frequency, become infrasound. Infrasound means below the frequency of hearing, below 20 hertz. The infrasound from the Chelyabinsk meteor explosion went around the world twice. You go around the world once, it's 40,000 kilometers. So the sound from Chelyabinsk traveled around the world 80,000 kilometers around the world twice, So I estimate that the explosion from the Penang bolide, if your infrasound detector, could have been detected in India, in China, in Australia. Or even we are very ambitious, can be even detected in Madagascar, on the east coast of Africa. So that's infrasound. All right. What about the light and the sound heard? All right. If at that time, let's say it was evening time, say 8 p.m., I'm very sure many of the Penang people are still awake. They would have heard it, and people on the road would have seen it. Especially those people in the west coast of Kedah would have seen it, would have heard it. But that time was 5 a.m. So most people are still asleep. So at the most you could have remembered was the sound, but not seeing the light. All right. So now, okay, that's about all. All right. CK, I go back to you. Yeah, okay.
Chicken, there is one question from the audience, Muhammad Altaf. So what is the purpose of an all-sky camera?
Yeah, later I can share about that. I'll be sharing that, yeah, in a while.
I think you can share it. I think Dr. John is finished, right? And my side, Saturn is not doing very well right now.
You want to?
Okay, I just.
Chunke, you want to tell your experience about the bolide first,
Oh, Ken, also I can add on a little bit to what Dr. Chong said earlier. Okay, actually this one was I think it's a first experience for all of us in Penang. We have read about this bolide thing, you know. We have seen the fireball capture in other country, in Russia, like in New Zealand, you know, in US a lot of time. But so far we have not really seen it happen in Penang before, and unfortunately, this event happening, like I said, is actually around 5 a.m. Okay, 5 a.m. Um, if we don't look up in the sky, we actually don't know. Nobody actually know, but just because that I suddenly I heard the sound, I didn't see the event. Then immediately when I heard the sound, I already know that it is something not very not very common. I mean, if we hear thunder, we can hear a lot of echo coming. You know, thunder coming, the boom. Then it has some side sound. I have heard like people shooting. You know, maybe shoot monkey or bird or whatever. So you can hear the gun sound also. That also have a lot of echo. But this one is very distinctive one. You can hear the sound very powerful one. They from the photo, from the video, there may be 2 or 3 explosion, right? There are some explosion, small one, then suddenly bigger one, then it disappear. But from what I remember, I don't remember hearing a lot of explosion. Maybe they mix into one, but I hear it as one single sound that boom, right? And there's no echo, there's nothing. It just boom. Okay, so immediately I know that it's not the sound is not man-made or not the thunder or lightning, you know. So it'll be something like high above me, you know, and come directly to me. So that was very interesting lah. And only later we found out slowly, you know, after I hear the sound, you know, inquiry, then Dr. Chong also just come back and check his CCTV that, oh yes, there's a sound at 502. Okay, then 502, then later only we found out that yeah, video are coming in and yeah, the explosion was like 2-3 minutes before that. So it was first time for us, you know. And yeah, I think we miss it lah. Maybe 5 o'clock in the morning, everybody miss it. I was out the whole night actually. I was out the whole night. From I think before midnight, 10, 11, I was out. I was taking images until the whole morning, until just after the explosion. Okay, and unfortunately, right now, if we take images, I mean, if we take images of the star and things like that, now right now we are actually quite lazy already. We don't stay out all the time. We just set up the equipment. We do some setting to the computer. Then the computer will actually take the photo by itself. So I was not out the whole time. Okay, I was only out like every half an hour to take a look that everything was fine. Then I'll go in again, then I'll come out again. Maybe I change to some target, then I'll take again, you know. So, but the one thing that I'm not sure is that throughout the night, I don't have any problem with my images, okay. But just before I heard the sound, actually my computer hanged. The camera was disconnected from the computer, so it was hanging there and waiting for response. So this is the first time I actually encounter this kind of problem. I do not know whether it's because of the explosion, the initial explosion, or something else, you know. But it was just a coincidence or something that my thing hang at that time. So as soon as I heard the explosion, then I hit everything. Then 15 minutes later, I think I tried to contact people, see whether anybody heard anything or not. Yeah. So I think that's my account now.
I can just add on to what CK mentioned about the computer hang. So my first thought was EMP, electromagnetic pulse. So it's like this. Maybe there's so much plasma created in the explosion. Plasma is what? Electrical charges. So when the electrical charges accelerate and so on, it creates an electromagnetic wave, a pulse of wave, right? So that's why it could cause computer to hang. Just to let you know, it could be that some of the defense departments like satellite, America, China, and so on in space have detected our body. Must look right, but they don't tell us lah.
Yeah.
Maybe they have detected one because in space all the time at geosynchronous orbit, right, 36,000 kilometers, the telescope looking down on the Earth. Basically, they're looking for those unauthorized rocket launching lah, all right, and so on. So if any rocket launch, visible light, infrared light. And if there's a last time, they will even have satellite looking down Earth for suspected nuclear explosion, gamma ray X-ray, given by nuclear explosion. So anywhere got this. So I'm sure the visible light could have been detected by some of the satellites, but they don't tell us. Right? So another thing what Kenny is that on my house, in my CD camera detected sound is like that. 5 seconds, it goes like that. Suddenly spike, and then take some time, 5 seconds, so very loud, then decay in about 5 seconds to decay. So that's a characteristic. So another one to let you know that we know that the property of thunder caused by lightning. We know that. Do you know? You heard a loud over your house, a loud lightning, thunder, what is the percentage of the energy of the given the lightning in the form of sound? The answer is 1% only. 1% of the lightning is given as sound. 99% is light. So what about the bolide? So the one I estimated is for the sound only. I don't know what percentage. Let's say 50% is sound, 50% is light. So 50% of sound is already 337 tons of TNT. So actually, that was an underestimate of the power of the explosion in Penang. It could be much more than that. Remember, 1% of the lightning energy is given as sound, 99% is light. Yeah. So, Kenny, you want to show your Oscar camera?
Yeah, sure. Let me put on presentation. Okay, so this is about the bolide meteor that captured by my all sky camera. The time is 4:59 a.m. in the morning of 21st of July 2021. Okay, so the left picture is showing the pictures that being captured. Okay, and it's actually a 1 minute stack picture. Okay, so this is I have this all sky camera which actually runs by Raspberry Pi, and it runs a program to stack the picture of 1 minute. It take picture for 1 minute and it stack up. Okay, so this is how the bolide looks like in the picture, and of course like Dr. Chong trying to explain earlier, the picture is supposed to be a round circle, because I'm using a 222 degrees lens. But then because of I do not want to capture my neighbor's window and my own windows, so I did not manage to put it onto the roof of my house. So windows are there, so I have to block it. Okay. So
Kenny,
this is
one
how
quick question, Kenny. What is the
yes.
direction of travel of this meteor?
Yeah,
Direction?
I will show that. Yeah.
Okay.
So okay, so this is the direction of how where the meteor flies. Okay, so the top of the picture is actually the southwest. Okay, and is flying towards the opposite direction, which is the northeast. Okay. Yeah, so this is how it flies. Do not be mistaken, because we see a lot of rocket launching, and we thought, actually it's flying to the top of the picture, but it's actually not. Okay, so what happened is the meteor enters our atmosphere. It have not exploded yet. That's why you see this entering in slowly getting brighter, and then this is where it starts to explode, right? Start to burn up. Actually burn up. Okay, so you can see it's getting bigger and bigger when it burns up. Okay. And this is a video taken by my surveillance camera, which just happened that I put a surveillance camera underneath my observer tree, pointing up, and you can see. I'm going to play it in a while, but you just look at this area. Okay, you can see my mouse. Okay, so this area is flying just on top of the wall here. Okay, so I have just played, is coming in another three, two, one, now. See? Okay, so you can see the meteor flying in this direction. I can just play again just in case you didn't catch it. Okay, now see? Okay, so this is the video captured by my surveillance camera. And I think just now also got people, someone asking, what is all sky camera? Okay, so here here I would like to share a little bit and uh, uh, to share with everyone basically what is the all sky camera and what is the benefits and what we can use for it, right? So all sky camera basically is a camera that capturing the whole sky, okay, the entire sky for a few different purpose, a few purpose, okay, meteorology, astronomy, or even some use for some solar energy study and so on. Okay, so the key important thing is it must be able to see the whole sky. Okay, oh, sorry, something like this, a round circle. Okay, and some use for day and some use for night. Okay, so like this you can see some stars. Okay, so of course my all sky target my all sky camera is targeted to actually capture the day and night events. And of the one important thing is I will be able to access remotely from anywhere that I want, so that I can see the sky condition outside my house, and I can prepare for my stargazing sessions. Okay, so here are some of the all sky camera that I've done. Other than the first one that I show, in fact, let me just flip back. Sorry. Uh, okay, so this first one that I have on the right hand side is my all sky that is running 24/7 every day outside my house on top of my car porch roof. Okay, and these other all sky camera are the one that I use, and the left one is I made for Dr. Chong to use on outside his house. These are all weatherproof, and this is more for capturing more better quality stars pictures. Okay, so because it the all sky camera that I put outside my house today that runs 24/7 actually after all the sun and rain and so on, the lens will burn up, the covers will get blur and things like that. So these are the one that I will only bring it up like the other few last few days. I bring it up for the meteor showers. So in fact, this was the one that I have been using for meteor shower. And last year December, Germany's meteor shower, I managed to capture 11 Germany's meteor shower meteors and two random meteors. Okay. So of course, all sky camera does not necessary to be in a weatherproof condition like this tree white color dome. If you want it to be portable and easy to carry around, it can be something like the left side, which is actually smaller than a palm size hand, your smaller than your hand size. Okay, so this can be powered by a 5-volt power bank like your handphone power bank. Okay, so you can bring it anywhere to take all sky pictures. Okay. So let me just share a little bit on the Germany's meteor shower that taken by this all sky camera last year. Okay, so this is outside my house. I did not put it on the roof. It was on the ground level, so you can see my gate, huh? And some stars are moving from east to west. Okay, there is a meteor. Okay, let me just play back a little bit. You can see some meteor here. Okay, I'll put a circle when there's a meteor fly through. There's another one. Okay, so you can see Orion constellation. Yeah, meteor pass by. Meteor. Okay, yeah,
Jenny, one question, you can have
yeah,
a software that can automatically detect the meteor.
yeah. That one needs some software graphical processing.
Yeah, but that'll be easy. You can auto detect, that'll be great.
Yes. So at the moment, I don't have that yet. But basically, I have these stacking pictures. So actually, this is all sky camera taking pictures 1 minute by 1 minute. So it just non-stop taking pictures, and for that 1 minute, it will stack up all the pictures that it has, and then produce one picture out from there. That's why you can see constellation Orion and many other stars that actually can be clearly see. Even like these covers, you see constellation covers can be seen here, right? So this is the advantage of this all sky camera. The exciting part is thing about this is that it costs if you just do DIY like what I did. We in fact we have conducted workshops to about 20 over people in the Astronomical Society of Penang. It costs us like 100 ringgit for a small module, and if you want to go for like all weather kind of stuff, weatherproof kind of stuff, probably it costs you about 500. Depends on the how to say the specs that you use. You can go for better processing power
Yeah.
Raspberry Pi, or you can go for lower end Raspberry Pi. It depends, right? So this is a very exciting thing where you can make. So if you are interested, you can actually contact us, the Astronomical Society of Penang. We could probably gather a group of people, and then we can conduct some workshop again for a second round of workshop to share with you. And I think with that, right, many more people have all sky camera. And if it's a weatherproof, is outside your house, you can capture the bolide meteor just like mine, right? So in fact, I was for my experience, I was asleep, so I practically did nothing. The
Yeah.
only thing is I'm lucky because I have a all sky camera that helped me to capture this. That's my experience for this bolide actually. Yeah.
Kenny, just want to add on one thing you forgot to mention, very important. The whole
Mhm.
setup is so friendly, you can control it with your handphone. Meaning what? Meaning that I put the outside
Yes.
outside on the roof of my house, and it's a secure fitting law. I travel anywhere in the world, and I'm sure that my Oscar camera is weatherproof for 1 month. I can check anywhere in the world through my house Wi-Fi. What's seen on the Oscar
Yeah.
camera? What's the weather condition? What's
Uh,
the cloud cover? What's the meteor? I'm now in Japan. I can show my friends in Japan. There. You can see the meteor flying over my house live. That's the beautiful part. Handphone control, not even an iPad. Handphone control. Okay, yeah.
Yeah, let me just show back. I think yeah, you remind me of this. I just ping into my all sky camera. Okay, so this is my all sky camera, which is right now outside my house. Okay, so I in fact I also captured the temperature inside the all sky camera box and the SOC, the processor temperature, and I have all the time, and this is showing the exposure time and the stacking time. So basically, right now the current setting is auto expose. I have done some how to say fine tuning on the light exposure, and I have a light LDR there to detect the light brightness. And with that, actually, right now is detecting and setting the exposure by itself, so that it's taking a picture every 6 seconds for 60 seconds. So after the 60 seconds, that means 10 pictures, it will stack the 10 pictures together and make it as one pictures. Okay, so yeah, as you can see, yeah, it is not perfect now because the the all sky camera has been outside my house for like many years, and the dome has degraded to become a bit yellowish, and you can see some lines of it, probably some that is refreshing. When it gets a new picture, it will refresh. Okay, so for every minute it will refresh. So
So,
today the sky,
Kenny, this is live,
yes,
live from your Oscar camera.
this
Also,
is live. Yes,
live, Okay.
yeah, this is live right now outside
That's
my
the
house,
moment.
and
Yeah.
you can see the quite bad. Okay, the moon is there, but it's badly with clouds. Okay, so in fact I have other things like showing the temperature for the whole day. Okay, and also of course the SOC temperature and the brightness of the environment. Okay, so if the sky is good, you can see stars, constellation with that. In fact, 2 days ago, I the not say 2 days. I think sorry, it was 3 or 4 days ago. The sky was quite clear, and I set up the other better all sky camera for the meteor shower, the Perseid meteor shower, and I managed to see that it is actually able to capture the Milky Way, a little bit of Milky Way, even outside my house in this Bayang Lepas area, which is badly light polluted. Okay, so I think that is what I have for the all sky camera. and how
Chicken,
the
there is
Meteor
a
is
question from the audience, Jared. He asked a spec of the all-sky camera.
Mhm.
What is the spec of the all-sky camera?
Oh, okay. So the all sky camera I made basically I use Raspberry Pi the credit card size computer as a platform. It's a computer that you can plug a camera right into it, and it does have a lot of I/O pinouts that you can actually connect to other things. Like what I have is a temperature sensor. I have a rain detectors, so on. Right. So the spec depends on what you use. You can use a very low end spec where the I can share that actually the Raspberry Pi Zero, which is really low end, and I think it just costs 40-50 ringgit. Okay, uh, let me show that to y'all. Okay,
Please share.
yep, I'm going to share now. A moment. So to be honest, I don't remember all the specs already with all this. Okay, so the hardware, yeah. Okay, so this is, if you are interested, you can go into this Raspberry Pi ORG. Okay, this is okay. So the left side, this is the smallest Raspberry Pi, but it does not easily connect to the camera. So the one that I use is this. Let me show you. Okay, so the one that I use is this. Okay, this is really small. Like I think how to say is probably 2 cm by 4 cm or 5 cm. Okay, so this is the Raspberry Pi Zero. If you go for this, you can still use it to capture. In fact, the Meteor shower that I captured was using this configuration, this Raspberry Pi. Okay, this is the smallest one. If you really want to know a bit more on the specs, let me see. Okay, it's here. It does have Wi-Fi on board. You need to buy a Wi-Fi version. There's another version without Wi-Fi. Have Bluetooth is 512 meg of RAM, 1 GHz of single core CPU. Okay, so the next thing is you need to connect it to a camera. The camera that I use actually bought over. I bought from China, Taobao. Some company selling 222-degree uh, Raspberry Pi camera basically. Yeah. So it's a version 2 Raspberry Pi. It's not the latest version 3 camera. Okay. Um, then of course, if you want slightly better spec, that means like the one that I have outside my house that run 24/7. The reason I use better spec for that is I use this Pi 3 model B. Okay, so the reason I use that is because right after the picture taken for whole day, 24 hours, I have a script that compile automatically all the pictures into a time-lapse video. So basically, I run the FFmpeg programs to compile all the pictures into AVI files, MP4 files, and then I can look at the MP4s to make my life easier rather than scrolling through 1,000 over pictures for one night. Yeah. So this is a slightly better one, but if you want to make one for outside your house, how to say, for 24/7, okay, where that means it will be under hot sun and so on. I do not recommend other models because the Pi 3B Plus and the Pi 4B is actually having actually the temperature is hotter if you run it, right? So under the hot sun, it could just reach maybe 70 over degrees Celsius, where is at the risk at the boundary of possible burn your chip. Okay, so this is a 1.2 gigahertz with 1 gig RAM, is slightly better than the Pi Zero W. Okay, I think that probably should answer his questions.
Can you allow me to add one more to what you said? Huh? Of course, just now, I hope the watchers and listeners don't be misled by what can you say, low cost, you know. He said the highest cost you make is like 500 ringgit. So what Kenny meant is not low cost, meaning low quality. Because compared to the all-sky camera of many years ago, for the present 500 ringgit quality get by the either computer and the optics, many years ago, it'd be many thousands of dollars many years ago. You don't have the technology, but now the cost has reduced, but the quality is even better. So low cost doesn't mean poor quality, good quality and rugged, temperature sensor, everything included. So don't be misled by the word low cost. Low cost meaning here is very high quality, good quality, and rugged, reliable. Okay.
Yeah. Because actually, if you search a professional all sky camera, it could be like 1,000 USD. So those things are very expensive. Of course, what we have here is based on the new technology where a credit card size computer can be put inside this whole small box that you can put outside your house to take pictures. So it's very useful, and actually, in fact, I installed this Apache web server inside, so that's why I can use my handphone and any tablets, iPad, whatever, to look at the conditions from anywhere. Right? Yeah.
One more thing, Kenny, you forgot to mention. Just now you saw Kenny put outside a few all-sky camera. Many of them are no wire one, all powered by a power bank. The power bank that charge your handphone can be used to power it. So in other words, what? You can take care of a picnic lah. You go to the beach, it's a portable, just leave it on the beach. Or if you can make many of these all-sky camera, low cost, one above your house, one above your company building, one anywhere you go, you can put, or you bring one portable one, so you can make many, right? And
yeah, in fact, I can
mobile data.
I can show. I Hello.
Yes, can see it.
Yeah. So Dr. Chong, I think in fact I can show. This is since you talk about the portability of it, right? I went to Korea a few years ago, and I was this in Maemon hotels, which I understand to be a hotel that people go stay to look for sunrise. So I set up this small Raspberry Pi all sky camera. Sorry. Okay, so I set up my all sky camera just at the balcony of the hotel because it was freezing cold, like I think 6 degrees Celsius. So I set it up there and I just go into the room and sleep, taking pictures for the whole night. And this is where I compile as a video. So if you really look at this, you can see the constellation Orion here. You can see the bright stars Sirius and quite a few stars coming up. Of course, unfortunately, the light pollution outside the hotel is quite bad, right?
And of course, it's just on Kenny. Your Korean camera is not pointing up, but Oscar is pointing horizontally, right? So it need not be
pointing
horizontally. So the Oscar camera can be used as a surveillance camera, horizontal one can be used.
Yeah, I point it horizontally because actually it's a balcony or hotel, so I could not see everything in the sky. So this is actually the right. If you look at let me share this. Okay, so if you look at the right top of the all sky camera, this is the one that I brought to Korea.
Yeah, the one below the one.
So this is a very small.
The one below on the right one, I saw we make on the workshop. It looks like your spectacle holder case. So
actually it's smaller than that.
Smaller than so nice,
Yeah. This is a junk stuff where I bought a charging cable for my handphone. It came with a small case. This case is about 2+ cm to about 4+ cm. About 4+ to 5 cm. So I put this Raspberry Pi Zero Wi-Fi version into it. Okay, and this is the camera. So if you can see, this is the camera. Maybe I can try to zoom in. Then move to that area. And unfortunately I did not prepare the pictures. But if you are interested in all sky camera, we can have a workshop or sharing section purely talking about this. Right. So if you can see, this is a small camera which is a 222-degree. And the interesting part about this, you can remove the IR filter of the camera. Hence, this is more sensitive for stars and even nebulas. Okay, so this is the inside it, the green color board. You can see this is the Raspberry Pi Zero W.
There's one comment, Kenny.
Yep.
Don't look down on the size of this camera and the lens. you must look at the quality of the video, then only you can believe it. Good quality, you know. Don't think it's small. No good. Good quality video, very sharp. Yeah.
Yeah, if I remember, is 3520 times 2592 pixels.
Yeah.
This version of camera that I have lah. Of course, if you choose 8 meg camera, the later one, then it will be better. Sorry. In fact, if you want to invest more, you can use the latest Raspberry Pi HQ cameras. Of course, the one a bit more expensive by the camera itself is probably a few hundred ringgit. I think 200 something ringgit.
Yeah.
Okay. Yeah. So, but anyway, it's still much cheaper than the one people sell the real all sky camera, which costs 1,000 over USD. Right. Yeah. Okay. Uh, I think that's all on this.
Any update on your side, CK?
Unfortunately, the cloud came in and refused to go out. I think there are more cloud coming in.
Yeah.
Look like there's no chance for it to see Saturn and Jupiter right now. Although Jupiter is coming up right now already, but yeah. So yeah, we'll try to bring more live in our next program lah. I think every week we have a program every Saturday, right? So for the ASP. So I hope that the viewer will come back, next Saturday and the following Saturday, and we try to show you live, because this month Jupiter and Saturn are opposition, so it's a great month to look at both planets. Okay. Oh, Daim is asking, right? Okay, what the difference between tonight and yesterday night and the night before? Is it that's what he meant? What? Yeah, I think it probably needs. Okay, why you want to see it now? I mean, like for example, Saturn opposition was in August 2nd, I believe. Now we are 2 weeks already after August 2nd. Is it smaller? We cannot see it now or what? But actually, Saturn is there all the time. It's just that for Saturn, which opposition on the 2nd of August, it is actually the time where we can see there are some slight changes on the Saturn ring itself, where we have got the Salinger effect. Maybe Dr. Chong can explain more on that. There's a brightening of the ring. I have not seen it properly, but yes, we did detect it that a few days before and a few days after the Saturn opposition, you can see that the ring actually brightened up considerably, and then it now start to dim back. So that is one of the effect that you can see during opposition or around opposition. Now it's already 2 weeks after that. So Saturn is while it is still very big, the size does not change a lot, but then that effect is getting more and more subtle. Okay. For Jupiter wise, we have the opposition next week. Okay, opposition next week. So from now on to next week, we may detect slight change in the size of the planet, although most of us will probably miss it. There are some slight changes. You're getting slightly bigger, but what is more pronounced is that there's a dim darkening. On one side of the Jupiter, where it's facing the sun, it is actually very sharp, and on the other side, you can see that it's slightly in the shadow a little bit. It's a little bit soft on one of the side, so you know that where the sun direction is coming from. But on the coming up next week, I think it's harder and harder to see. So you can see that Jupiter is just very nice circular. Not really circular, a bit oval, a bit, yeah. But there's no much difference between the left side and the right side of the Jupiter. That's what I can see. Maybe Dr. Chong and Chicken may have something more to add.
Yeah. So I have nothing to add except that nobody asked me, Michael, the question. Maybe I will answer it myself.
No, actually, there's another question from Dime also. He asking whether all this planetary alignment affect us in any way, gravitationally, astrologically, or metaphysically. Because people are always
Yeah,
talking
Dr.
about
Chong
this
cannot
planetary
answer that.
alignment will create end of the day.
Well, allow me to answer. So this kind of question, they have been hearing from members of the public, even from the people we know in USN for years and years now. So basically, there are two ways to answer it. If you want me to answer from the scientific aspect, I can. If you want to ask me from the human psychology part, I cannot answer lah. For example, you say that now the planetary alignment, tsunami, end of the world, should I sell the share? Should I go and sell my house or not? That one I cannot answer. It's all acting on the minds of men. But scientifically, I can answer that. Now you have this planet aligned, previously no alignment. Will the effect of gravity of this alignment be more on my head or less? You think carefully. Everywhere, any two mass on the universe will have a force, inverse square law, like m1 times m2 divided by r squared times gravitational cos constant. Now, these planets, Jupiter and so on, so far away. They may align in a different way, but they're still far away. So the difference in the increase or decrease in the gravity force due to the position of this planet, will it be a lot of change in the gravity? No change. No change. The only thing that can change in the psychology of human being, that is that thing I can answer. So we are answering the first way, scientific way. No difference. Yeah. Now I answered the other one. Nobody asked. Okay, allow me. I share my screen. Okay. Okay. Just one slide. The last slide. Now, earlier I asked a question is that, all right, can we have a perfect Saturn opposition where looking down from polarities, we see the Sun, Earth, Saturn line is a straight line. And looking along the plane of the optical plane, the Sun, Earth, and Saturn also on a straight line. I said that very unlikely, but not zero like. It can happen. How? Like this. You take the example of the solar and lunar eclipse that can occur. This case is the sun is on the right, the earth is in the center, the moon is orbiting the earth law, the blue line, and although it's the earth orbiting the sun, but now we take as if the sun orbiting the earth. So now you find that the moon's orbital plane around the earth and the sun's orbital plane around the earth also are inclined, right? Inclined for the case of our earth and moon is about 5 degrees. So anywhere the moon on the blue line cannot have a lunar eclipse or eclipse. Only at the intersecting nodes, ascending nodes, descending nodes, you can have both of the planes intersect. Then you can have a lunar eclipse and a solar eclipse. Similarly, you can have a perfect Saturn opposition occur where the orbital plane of Saturn around the sun, the orbital plane of Earth around the sun, they intersect at this line. So what happened? So here on top here is the sun, and here is, let's say, the Saturn, here's the Earth on a straight line. Then this can occur. But the problem is this: the moon orbit the Earth once every month. So solar lunar eclipse can occur very often. But what is the orbit of the Saturn around the sun? Orbit of Jupiter around the sun, many years, So for it to have the intersecting node occur is very rare. And human beings don't live. It may occur once in, let's say, a few 100,000 years, but we are not there to see it. So it can occur, but very hard to see. All right, that is during opposition of Saturn. On both way you look at it, looking down from polarities, a straight line. Looking at the orbital plane, also a straight line. It can occur. Perfect Saturn opposition, but very rare. Okay, that's all.
There's another question from the audience. I think she's asking whether we can see the planet with the naked eyes.
Yeah.
CK, maybe you can answer
CK,
that.
For you, CK. Can we see the planets?
What's the question again?
Can we see the planets with our naked eyes?
Oh, can we see the planet? Oh, yes. Actually, we can see the planet with the naked eyes. Okay. Okay. What do you do that? Okay, every day, these few weeks, if you want to catch the planet, you look toward the east after the sunset. You look toward the east. You will be able to see. Let's say if you after your dinner time, you look toward the east. You should be able to see something like a yellow color star. okay, look like a yellow color star. That is Saturn. Okay, to confirm that there's a Saturn or not, wait for a while, maybe about 10 o'clock, 11 o'clock at night. When you see this yellow star going up higher in the sky, try to see whether there's another star at the bottom of it, slightly lower. It's a bit white color, very bright, and that is Jupiter. Okay, so if you observe these few days, look toward the east after the sunset, then try to see one yellow star, and you see and one bright white star. The yellow star is Saturn, and the white one lower is Jupiter. Of course, with the naked eye, you can see them just like a star. Maybe it's brighter than the normal star, but then you will not be able to see any surface feature. Okay, you need a small telescope, maybe about small telescope with which you feel about 70 times, 80 times magnification. Then you can see maybe Saturn with a ring. Okay, so but don't be disappointed. Although the weather is suddenly turned quite bad, we have a talk, and live webcast almost every Saturday. So please follow our website, our Astronomical Society of Penang Facebook page. We'll update you on the next event, online event. Okay, since it's MCO, and we are trying to share with you more live images of Saturn and Jupiter. Okay.
CK, I'll just add on. I'll try to generalize what CK is doing. That is, can we see the planets with our naked eye? Of course, CK said yes. Let's generalize. That is, our human eye. Imagine you're in a place which is very dark. You have perfect eyesight, no clouds, no moon. You see thousands of stars. Your eye can see down to magnitude 6.5, very dim, right? So basically, magnitude 6.5 means what? Uranus magnitude 5.7. With your naked eye, under the best condition, you can see Uranus as a point now, not as a big object point. So basically, with your naked eye, you can see Mercury, you can see Venus, very bright, Mars, Jupiter, Saturn, and Uranus with naked eye. You know the spot you're seeing is that planet. You can see up to Uranus with your naked eye. Yeah, okay. Any more question, Michael? Good, very good session. Okay. So thank you, CK, all the way to your observatory. Thank you, Kenny, and thank you, Michael. Thank you. Okay, you can end.
Okay, so
Thanks,
thank you
everyone.
everyone for joining us tonight. So we hope to see you again. So so stay tuned and check out our Facebook page as well as our YouTube channel for any update on our future events. Okay, good night and see you again. Thank you.
Bye.
Thank you. Bye-bye.